Good day, friends. You are welcome to my YouTube channel, Mathematics Made Easy. In today's video, we'll be solving this particular problem. That is, I want to prove this integral. This is called Bose Integral. So I want to prove that gamma of s multiplied by the zeta of s is equal to integral from 0 to infinity of t raised to the power of s minus 1 over e raised to the power of t minus 1 dt. Okay, solution. So this is the first thing I will be writing down, the gamma of s, the representation, the integral representation of gamma of s. So gamma of s is equal to integral from 0 to infinity of x raised to the power of s minus 1 e raised to the power of minus e raised to the power of minus x dx. So this is the representation of our gamma of s. Then I will also write down the representation of zeta of s. Zeta of s is equal to summation. So it's starting from 1 to infinity of 1 over n raised to the power of s. So we'll be needing this and this for us to be able to prove this identity. Alright, so let's get started. Let's dive in to our work. Alright, so what can we do here to prove this identity? So I will start the proof from the representation of gamma, the integral representation of gamma function. Okay, so now from this gamma function we have gamma of s is equal to integral from 0 to infinity of x raised to the power of s minus 1 e raised to the power of minus x dx. So now what can I do here? So what I'm going to do here is to make a substitution. That is, I can say put x to be equal to n multiplied by t. So if x is equal to n multiplied by t, we are going to have dx is equal to n dt. Okay, so we have x is equal to nt and dx is equal to n dt. Take note of that. So the limit is not changing. Why? Because if I put 0 here, it will still be 0, and if I put infinity, it will still be infinity. So then I have gamma of s is now equal to integral from 0 to infinity of x is now nt raised to the power of s minus 1 e raised to the power of minus nt and dt. So if you apply the law of indices here, nt raised to the power of s minus 1 multiplied by n, so this will just be gamma of s is equal to integral from 0 to infinity of t raised to the power of s minus 1 e raised to the power of minus nt and raised to the power of s dt. This if you apply the law of indices over there. Now n raised to the power of s is a constant, so I can bring out n raised to the power of s from that integral sign. So bringing that out, so I'm going to have gamma of s is equal to n raised to the power of s multiplied by integral from 0 to infinity of t raised to the power of s minus 1 e raised to the power of minus nt dt. Okay, so what am I going to do next? I'm going to divide both sides by n raised to the power of s. So dividing both sides by n raised to the power of s. So I am going to have gamma of s over n raised to the power of s is equal to integral from 0 to infinity of t raised to the power of s minus 1 e raised to the power of minus nt dt. Okay, so after the division, so that's what we are going to have. So the next step is to introduce the summation to the both sides. That is taking the sum of both sides from n running from 1 to infinity. So introducing a summation here. So if I introduce summation from this particular side. So I'm going to have summation of n from 1 to infinity of gamma of s over n raised to the power of s is equal to summation of n from 1 to infinity of integral from 0 to infinity of t raised to the power of s minus 1 e raised to the power of minus nt dt. Okay, so we have that now. So since we have this now, what can we do next? So this is what we can do since we already have this. Okay, gamma of s is not a constant. Okay, gamma of s is a constant because it's not having n. And if you look at this right hand side, this e is having n, so I can bring this summation into this integral sign. So I'm going to have gamma of s multiplied by summation of n from 1 to infinity of 1 over n raised to the power of s, which will be equal to integral from 0 to infinity of t raised to the power of s minus 1 summation of n from 1 to infinity of e raised to the power of minus nt dt. I'm sure you are following me. Alright, so after these parts, so don't forget I said summation of n from 1 to infinity of 1 over n raised to the power of s is just zeta of s, and then this particular sum here, summation of n from 1 to infinity of e raised to the power of minus nt, is just 1 over e raised to the power of t minus 1. Okay, so we are having what we need. So this is zeta of s. I'm going to have gamma of s multiplied by zeta of s is equal to integral from 0 to infinity of t raised to the power of s minus 1. So this is now this multiplied by the t over e raised to the power of t minus 1. So gamma of s multiplied by zeta of s is equal to integral from 0 to infinity of t raised to the power of s minus 1 over e raised to the power of t minus 1 dt. So then that's the proof to the given identity, that is prove that gamma of s multiplied by zeta of s is equal to integral from 0 to infinity of t raised to the power of s minus 1 dt. Then we are done with the proof of the Bose integral. Please don't forget to subscribe to my channel. Please, I beg of you. Don't forget to share. Don't forget to subscribe. Don't forget to comment. And don't forget to like. God bless you. Meet you in our next class.